Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. Dear students, open your books and come on page 49. Today, my topic of discussion is attraction and repulsion of the magnet. And at the end of this lesson, you will be able to show how magnets and electromagnets can be used in a number of devices and to distinguish between magnetic and non-magnetic materials. Before starting today's lecture, let's preview your previous lecture.
समय पास
Previously,
मैग्नेट है
we were talking about the magnetism. So, magnetism refers to the properties, interactions of magnets, how a magnet should be interacted with different materials or different metals, and what will be the impact of that magnet upon those materials. Then we were talking about the magnetic force. Magnetic force is the interaction between the two magnets, that the force will be attractive or repulsive, and the force with which it attracts every other body in its surrounding. So that is so-called magnetic force. Basically, a magnet is surrounded by a magnetic field that exerts the magnetic force. The space or region around a magnet, we can say a magnetic field. And that in that field, if a magnetic material or a metal is placed inside that field, then the force of attraction or repulsion will be experienced there. The magnetic field is strongest closer to the magnet, and it will be weaker away from the magnet. If you come close to the magnet, then you will experience a higher magnetic force, or a strongest magnetic force should be influenced upon that object. And if you move away from the magnet, then their force will be weaker and weaker. So this is all about your previous knowledge or your previous lecture. Now come towards today's lecture. Today we will be talking about the attraction and repulsion of the magnet. Previously we were talking about the magnetic force. The magnetic force will be attractive if the two opposite poles of the magnet will come closer. For example, the south pole come closer to the north pole, we can say that attraction will be there, and vice versa. Beside this, if the two like poles of the magnet should come closer, then they will be repel each other and repulsion will be there. For example, if north pole will come closer to the north pole of the magnet, then we can say that a repulsion or a repulsive force will be experienced there, and as a result, they will be moved away from each other. Similarly, with the case of south pole, if you bring closer the south poles towards each other, then we can say that these poles will repel each other. So this is all about the attraction and repulsion. Here in this figure, you can clearly distinguish how the magnets works. Okay, so in first term, atomic structure, the atomic structure of the non-magnetic material, this is so-called, this structure is the structure of non-magnetic material. You can see here that its outermost shells are almost completed. You can clearly see here, but in this structure, you can see beside this, in this structure, you can see that the atomic structure of the magnetic material, half shell of electron. Okay, this shell is incomplete, so we can say it half shell, and beside this, the non-magnetic material, their outermost shells are completed. There is no free electron, so we can say that no magnetic experience will be there. And these are so-called half-shell electronic configuration. So we can say these are a magnetic material. All the materials in which their outermost shells are not completed or partially completed, we can say non-magnetic materials. Come towards the second point, this point, you can see here, this is the structure of a magnetic material. This is the structure of a magnetic material, and it will experience a magnetic effect like this. You can see like this, okay? So in this case, we can see that the half shell magnetic material or magnetic objects, we can say it behaves like a magnet. Come towards the third point. Look at this picture. There are number of magnetic atomic crystals. So a collection of magnetic atomic crystals form a domain of magnetic field. You can see here that in this case, the the south pole is showing the domain, and the north pole beside this. They are aligned. Okay, we can say that in this form of the magnet, we can say this is the aligned particles are aligned magnets to form a domain of the magnetic field, which are then all aligned in the same magnetic direction. You can see there that in each and every case, the domains are aligned in a specific direction. All of them are specified, are pointed in a specific direction. You can see here in this figure, they will directed toward the left side and they will directed right above the right side. Okay, so all of them are showing their domain. Magnetic materials in collections with the magnet, the domains of the materials align themselves with the domain in the magnet. You can see here that it will align themselves according to the situation, according to the scenario. If the North Pole will come closer to this, then it will align towards that North Pole. The South Pole will be aligned towards the North Pole. And if you align the South Pole, then the North Pole will come closer to that and it will be aligned, the North Pole will be aligned towards that pole. So making it a temporary magnet. Come towards the fifth point. All magnets have south and north pole. In each and every particle, you can see here that they have two poles. One is blue and the other one is red. The red one is so-called north pole and the blue one is so-called south pole. If you break the magnet into pieces, then each and every piece behaves like a magnet. They will become like a magnet and there are two poles will be aware at that particles. So all magnets have south poles and north poles. You can see here, this is the south pole of this magnet and this is the north pole of this magnet. And you can see that opposite pole attracts each other. In each and every time, you can observe that the opposite poles will always and always and always attract each other. Look at this figure that the south pole come closer to the north pole and the north pole come closer to the south pole and they will be attracted each other and they will meet. Polarity causes a magnet to stick to each other. You can see in this figure that both the magnets were stuck to each other. Now come towards the sixth figure. This is the figure that polarity causes magnetic material to stuck to the magnets. You can see here these are the magnetic materials. These are the magnetic particles and these particles are struck to the different are the two poles of the magnet. Come towards the seventh point that like poles are always repulse each other. You can see here that if you come closer or you bring closer the south pole to the south pole and north pole to the north pole, then you will observe that a repulsive force will be experienced there and they will trying to move away from each other. So unlike poles or opposite poles will attract each other and like poles uh, will always repel each other. Come towards the attraction and repulsion. Attraction, opposite poles attracts or come together, north and south pole. You can see here in this figure that north and south pole will come close together and they will be attracted. Repulsion is like poles repulse or push away each other. North pole and south pole will repel each other. Come towards your book page. Attraction and repulsion. You can see here this is a bar magnet. Okay, this is a bar magnet. If you suspended it like this, this is so-called the pre-suspension or freely suspended bar magnet. So if you freely suspended the bar magnet, it will be always and always point like north-south. One side of the magnet will be pointed towards the north and the other one will be pointed towards the south. Always and always, if you suspend freely a bar magnet, it will point it towards the north and south because because the north pole is always at positive terminal and the south pole is always at negative terminal. So if a bar magnet is dipped into an iron fillings, the fillings stick to its ends. You can see here that these are the iron fillings, okay, and they will stick towards this bar magnet. So the magnetic force seems to come from 2 points. These are called poles of the magnet. Each side of the magnet is so called pole. Okay, each side of the magnet is so called pole of the magnet. The earth affects magnet. If the bar magnet is hung from a thread, it's eventually settled to point roughly north and south. Okay,
Sir,
already I told you that if you suspended a bar magnet, then eventually it will direct it towards north-south. The end of the
sir,
magnet, which points to the north, is called the north-seeking pole or N. Okay, the sides of the magnet, that side of the magnet which points toward the north, they were so-called north-seeking pole, or we usually represent that pole is N, and the other end is south-seeking pole or S. That is pointed towards the south. We can say that south pole. If two magnets are brought together, like poles repel and unlike poles attract. Already I told you that the like poles of the magnet attracts each other, repels each other, and the unlike poles of the magnet will always attract each other. The
sir,
closer the magnets are, the greater the force between them. Yes?
सर आप उर्दू में समझा दें.
Okay, then I will explain this in Urdu. Okay, now this is the attraction and repulsion. You can see here that always the like charges will repel each other. So repulsion will be there like this. These are so similar charges. Though both of them were positive charges. So repulsion is there. The neutral charges will always no force of attraction or repulsion. And the opposite charges will always attract each other. So from this figure, you can clearly see that like charges always repel and unlike charges always attract each other. Now come towards your book page, magnetic field. You can see here in this figure that how the magnetic field works and how the magnetic field should be utilized here. A magnet has a space all around it where magnetic materials feel a force. There were so-called magnetic field. We say that there is a magnetic field around the magnet. You can see here are the space or region around the magnet in which the force of attraction or repulsion experienced there. We can say a magnetic field. Magnetic fields can be studied using a plotting compass. With the help of this, you can see here this is a compass. Okay, you can see clearly see this is a compass. By with the help of the compass, you can point it which side is north and the other one is south, because it opposite side will always attract each other. So if you pointed the compass, it will give you the direction of the magnetic field lines and as well as the poles of the magnet. Okay, so in a magnetic field, its north pole is pulled one way and its south pole is pulled the other. One will give you the north pole and the other one will give you the south pole. The needle always comes to rest in line with the magnetic field. You can see here, the needle will always point it. You can see this is the needle. So clearly it will point it in one direction. Here in this point, the needle gives you an idea about the north pole, and in this point, it will give you an idea about the south pole. The diagram shows the field patterns of the bar magnet. You can see here, this is the diagram, and this is the field points or field patterns of the bar magnet. These are the magnetic field lines, we can say. Only a few lines are drawn to show the shape clearly. There are millions and billions of lines, but here just only few lines were drawn here because to show you how the magnetic field lines. It will comes out from the north pole and it will enter to the south pole. Always. The spacing between the lines shows in the strength of the field. Where the lines are close together, for example, near the pole, the field is stronger. You can see here in this figure that you can see here the field is stronger, and at the middle the field is quite weaker as compared to the ends. So from this figure you can clearly see that how strongly the field lines are here, and you can see at the middle the field lines are not quite stronger as compared to the end points. So the spacing between the lines shows the strength of the field. Where the lines are close together, for example, near the poles, the field is strong. Okay, so at poles, at each sides, the lines will be stronger and the magnetic field will be stronger there. And at the middle, the field will be weaker there. The arrows on the field diagram shows the direction of the force. You can see here, these are the arrows from which you can distinguish this is the direction of the force. The force is directed from north to south, so that's why it is directed from north to south. Notice they always runs from the north to south. If you passing a current, then you can see here from this, these are so-called magnetic lines. Around each and every wire, a magnetic field is generated there. Okay, so we can say that a magnetic field lines. From this figure, you can clearly distinguish that how the magnetic field lines should be experienced there. These are the magnetic field lines which is coming from the North Pole and which is enters to the South Pole each and every time. You can see here that it will be generated from the North Pole, and the spacing between the two lines will give you an idea about how stronger or weaker the magnetic force is. So these are the magnetic field lines. I'm sure that from this figure, things will be quite clear that how the field lines will be coming from each and every bar magnet and how it will enter to the other pole of the magnet. Remember one thing, that in each and every field line, they will not intersect with each other. No field line will intersect with each other. Okay, because they were always and always perpendicular in direction to the point. Okay, to the point or to the pole of the magnet. So we can say that the magnetic field lines will be generated from North Pole and it will not intersect each other. This diagram shows the magnetic field pattern produced when unlike poles of the two magnets are brought closer. You can see here that if you brought the two unlike poles like North Pole towards South and South Pole towards North, they will always attract each other, or they will be come closer towards each other and they will stick to each other. This diagram shows that magnetic field patterns produces when like poles of two magnets are brought closer. You can see here that these lines will striking with each other, and as a result, it will resist the two poles to not touch each other, or it will move away from each other because the field lines will strikes with each other, and as a result, it will bounce back the poles, the like poles. Come towards an interesting information about you. The earth core is thought to contain a lot of iron. We consider, or the scientists consider, that the core of the earth or the center of the earth is made of iron. It is this iron that causes the earth magnetic field. Okay, so that causes the magnetic field because iron is a magnetic material. So we can say that it will influence the magnetic field of the sun, and as a result, it will be quite rotating accordingly. The Earth's magnetic north pole is about 700 miles. It's quite tilted from one side. It quite sides from one side, so it will be tilted about 700 miles from its actual north pole. So it will be like at certain angle. It will be like bended. So from the geographic north pole, and you can see this is the Earth. I hope so that things will be quite sure to you all. Now, today's lecture summary is we were talking about the magnetic field, the space or region around the magnet where its force of attraction or repulsion experience. We can say that a magnetic field. A suspended bar magnet will point roughly north and south. The unlike poles of the magnet will always attract each other, and the like poles of the magnet will always repel each other. Now, here is an assignment for you. So you should answer this question and you should send me on my WhatsApp number. I will check and then I will tell you that whether your answer was correct or not. Thank you so much. This lecture will be available there on your YouTube link also. If anybody have any questions regarding this lecture, you should ask. And inshallah, tomorrow we will discuss page 50 and 51 of your book.
क्वेश्चन
Now,
आंसर्स खुद
सर
करने
क्वेश्चन आंसर
पड़ेंगे।
भेज देंगे।
सर क्वेश्चन आंसर भेज देंगे।